this video, we're going to take a look at questions that involve finding all of the values for an angle. If it says find all of the values for an angle, you have to immediately go to the cast circle. So the first thing I would do for myself, because I've noticed they've said find all of the values, I'm just going to sketch my cast circle out of the side. Maybe I won't need it and I'll be able to work it out without it, but for me, I would write down the cast circle. When I want to find an angle in general, what I need to do is have sine on its own, and then I would get sine inverse on the other side. So I don't want that 2 to be there. So if I don't want that 2 to be there, I'm going to divide both sides by 2, and then I'm going to have sine of x all over 2 is equal to minus root 3 all over 2. So that's the first step. After that, I want to get the angle, so I'm going to have sine inverse of the other side. Now, something interesting is going to happen when we do that. If you put in sine inverse of minus root 3 over 2 into your calculator, it'll give you only one value. But that's not true. There's not only one value for it. There's 2, because that negative is telling me that the value of the angle, where the angle is it's in a negative quadrant for sine. And sine is negative in 2 regions. It's negative in the T region and it's negative in the C region. So what I'm actually going to do first is I'm going to find a reference angle. And I'm going to find that reference angle by ignoring the negative for a moment. And I'm going to just do that sine of my reference angle A is equal to root 3 over 2. So A is equal to sine inverse of root 3 over 2. And if I put that into my calculator, then that's going to give us our reference value. So sine inverse of root 3 over 2 in my calculator is giving me 60. So that means that I am 60 degrees over here. And I am 60 degrees down here. Okay, but remember, I don't want the reference angle, because the reference angle is just 60. I want it when is sine going to give us a negative value, which is all the way around here, which that line there along the middle, that line is the 180 mark, and I've passed the 180 mark and gone past it by by 60, so it's 240 is the x over 2, the angle that I've actually done, the original angle. That's what I've done when I go around here. So A was only the reference angle. I'm now actually trying to find if I have sine of x over 2 is equal to minus. So there was 2 answers. So what I can actually write now is I can write that's x over 2, because I've done the sine part, I've worked that out, and I've worked out that x over 2 is equal to 240. And then if x over 2 is 240, then x is equal to 480. In this scenario then, I'm going to just pause that and go to the other one, which is in this quadrant. And if I do that rotation right the way around from the start, I'm almost at 360, but I stop short of 360 by 60 degrees. So that purple rotation, which is x over 2, is equivalent to doing 300, because I've stopped short of doing the full 360 by 60 degrees. And I'm going to double that. So x is equal to 600. Now, the question didn't ask us to do it in degrees, it asked us to do it in radians. So I'm going to convert those into radians now, and how we do that. So if you're stuck, if you have done this and you didn't do it in your calculator using radians from the start, you could, it would make life so much easier. But how do I do it if I'm here? So remember that 2 pi radians is a full circle, and that's equal to 360 degrees. if I want what 1 degree is, I'm going to divide both sides by 360. So I know that for every 1 degree that I have, I actually have 2 pi over 360 radians. What I'm going to do now is I'm going to say, right, if that's 480 of them, one of them is worth 2 pi all over 360. So what I can do is multiply. So I'm going to multiply in my calculator 480 multiplied by 2 pi all divided by 360. That gives me 8 over 3 pi. And if I work out this one, I'm going to do 600 times 2 pi all divided by 360. And if I do that, I'm going to get 10 pi over 3. So here x is equal to 10 pi over 3. So there's 2 values that I have for potentially for x. Okay, now there is more than 2 values because they've said that I'm allowed to go up as far as 4 pi. So how do we get more out of it? If there's only 2 quadrants where sine is negative, how do I get more angles? Well, we need to remember that if I am here and I do a rotation right the way around, and I do a rotation of 2 pi, I end up in the exact same position again. So if I add on 2 pi to that, I end up in the exact same spot as I was in before. So that's also a solution to that question. So I could have x is equal to 8 over 3 pi. So let me just move our little notes on radian conversions to the side. I could also have that x is equal to 8 over 3 pi, and I could add 2 pi to that. And so long as I don't exceed the value of 4 pi, I am allowed to include it. So 8 over 3 pi plus 2 pi, that's going to give me 14 over 3 pi. So 14 over 3 pi. Okay, so you can check that that doesn't exceed your 4 pi. 4 pi is 12.56. 14 over 3 pi works out to be 14.6. So actually in that case we can't add on our 2 pi because it exceeds, that's greater than 4 pi. And they said to stop when we get to 4 pi. I'm going to check the other one to see if we can add to that. Very unlikely though. It's actually definitely is not going to happen because if 8 pi over 3 was too big, 10 pi over 3 is definitely too big. So x can't equal to 10 pi over 3 plus 2 pi. That won't happen. In some scenarios it does work out, in this one not so much, because we already had to double the angle and we already exceeded that 360. So just take your time, test it out. If you're not sure, put it into your calculator, test out your values. But in that scenario we didn't have to add on the 2 pi, it exceeded the 4 pi, so we stop at the 2 values that we got.